Welcome to our channel. We are so glad you found your way here. Let us help you fall asleep. Let's begin with the multiverse theory, infinite realities to fall asleep to. Take a slow, deep breath in and release it. Let the weight of the day fade away as we embark on an unhurried, atmospheric journey through the wonders of the cosmos. Your mind is quiet, the universe is vast, and we are ready to explore. The concept of the multiverse encompasses a multitude of potential realities, each operating under distinct sets of physical laws and constants. This framework arises from interpretations of quantum mechanics, where particles exist in superpositions, allowing for the emergence of multiple outcomes simultaneously. Each possible outcome could manifest in its own universe, leading to an infinite array of possibilities. Different models of the multiverse propose varying structures. The bubble universe model suggests that our universe is just one of many bubbles, each containing its unique laws of physics. In contrast, the many worlds interpretation indicates that every decision creates divergent paths, resulting in a branching of realities. These interpretations challenge the traditional view of a singular universe, suggesting a more complex and layered existence. The implications of this theory extend beyond mere existence. They touch upon the nature of reality itself. Each universe may house variations of our own experiences, leading to profound questions about fate, choice, and existence. The potential for encounters with alternate versions of ourselves raises ethical and philosophical considerations. Research continues to evolve, exploring the boundaries of this theory while examining its mathematical foundations. As scientists delve deeper, the multiverse remains a tantalizing subject, inviting inquiry into the very fabric of reality and our place within it. Philosophical origins of the multiverse trace back to ancient thinkers who pondered the nature of existence. In the 4th century BCE, the atomists proposed that an infinite number of worlds could arise from the collision and rearrangement of indivisible particles. This notion suggested a universe far beyond the observable, hinting at a reality filled with countless possibilities. Fast forward to the early 20th century, when quantum mechanics emerged, revolutionizing the understanding of subatomic behavior. The concept of superposition, the ability of particles to exist in multiple states simultaneously, laid the groundwork for interpretations that embraced a multitude of realities. The Copenhagen interpretation and many worlds hypothesis both emerged as potential explanations for quantum phenomena, each suggesting that each decision or event could spawn an entirely separate universe. These ideas found fertile ground across various philosophical landscapes, resonating with existential inquiries about choice and consequence. Thinkers like David Lewis articulated modal realism, postulating that all possible worlds are as real as the one we inhabit. This perspective influenced modern physics and encouraged an exploration of the cosmos beyond empirical observation. The interplay between philosophy and science continues to shape the multiverse discourse, blurring lines between reality and speculation. Each advancing theory contributes to a deeper understanding of existence, further unraveling the mysteries of the cosmos and humanity's quest for comprehension. Quantum mechanics serves as a fundamental building block in understanding the multiverse theory. This domain of physics reveals the peculiar behavior of particles at the smallest scales, where classical intuitions break down. At this level, particles can exist in multiple states simultaneously, a phenomenon known as superposition. This characteristic underpins the idea that every event may spawn numerous alternate outcomes, each developing into its own distinct reality. Entanglement introduces another layer of complexity. When particles become entangled, the state of one immediate particle remains linked to another, regardless of the distance separating them. This interconnectedness suggests a deeper framework of existence, challenging conventional notions of separateness in a universe that may contain parallel dimensions. The implications of these quantum principles extend beyond the realm of physics. They prompt philosophical inquiries about the nature of reality, free will, and the very fabric of existence. If multiple realities exist, the choices made by conscious beings could lead to diverging paths, each manifesting its unique consequences. Exploring these theoretical foundations fosters a profound appreciation for the intricacies of the cosmos. Each layer of understanding reveals the delicate balance between observation and reality, hinting at endless possibilities that lie beyond the observable universe. Thus, the multiverse theory emerges, shaped by the enigmatic principles of quantum mechanics. Classical realities operate within a framework governed by predictable laws of physics. Objects exist in defined states, occupying specific positions in space and time. This consistency allows for a structured understanding of the universe, providing clarity in observation and measurement. In stark contrast, quantum mechanics introduces a world where particles exist in a state of superposition. Here, they can occupy multiple states simultaneously until an observation collapses this ambiguity into a single outcome. In this quantum realm, the behavior of particles defies classical intuition. A single electron, for instance, can be both here and there, existing in a cloud of probabilities until interaction forces a definitive state. These phenomena challenge the foundational perceptions of reality that underpin classical physics. This region of study reveals a universe intertwined with uncertainty, where the act of measurement influences outcomes, and yet entanglement further complicates the landscape by connecting particles regardless of distance. Changes to one particle instantaneously affect its counterpart, suggesting an interconnectedness that transcends classical limitations. Such relationships hint at deeper layers of reality, where classical and quantum realms intertwine. The implications of superposition and entanglement extend beyond theoretical physics, prompting questions about the nature of existence itself. In this exploration of reality, understanding becomes an intricate balancing act between certainty and possibility. Hugh Everett III's contribution to the many worlds interpretation introduces a framework where every quantum event branches into distinct realities. This concept posits that all possible outcomes of a quantum event actually occur, each in its own separate universe. This idea diverges from traditional interpretations that collapse wave functions upon observation, suggesting instead that the universe remains in a superposition of states. Within this framework, every choice, every action, and every random event spawns a multitude of parallel universes. These realities coexist, with each one representing a different outcome. The implications extend into philosophical realms, challenging notions of free will and determinism. Each decision creates a branching pathway, leading to an infinite array of experiences and dimensions. The mathematics underpinning this theory utilizes complex wave functions, illustrating how particles exist in multiple states simultaneously until observed. Each universe operates independently, yet remains interconnected through the fundamental laws of quantum mechanics. This viewpoint reshapes the understanding of reality, presenting it as an expansive landscape rather than a singular existence. Only in the context of cosmic exploration, such interpretations provoke contemplation about the nature of existence itself. While the many worlds interpretation may seem abstract, it serves as a reminder of the vastness that lies beyond the observable universe, inviting inquiry into the very essence of being. The observer effect reveals the intricate relationship between measurement and reality in the realm of quantum mechanics. This phenomenon suggests that the act of observation can influence the state of a system, intertwining the observer with the observed. In this context, it becomes evident that particles exist in a state of probability until they are measured, collapsing into a definite state. This relationship presents profound implications on the nature of reality, emphasizing that it is not just a passive backdrop, but an active participant in the unfolding events. Experiments designed to illustrate the observer effect, such as the double-slit experiment, demonstrate that particles can display wave-like behavior until an observation occurs. This duality challenges conventional notions of existence, suggesting that reality may be contingent upon the presence of an observer. In microscopic realms, it becomes difficult to separate the observer from the phenomena being studied. This region of quantum mechanics propels inquiry into philosophical questions regarding consciousness and the fundamental nature of reality. It prompts exploration into whether observation itself creates reality or merely reveals it. Understanding the observer effect could reshape perspectives on existence, allowing for deeper contemplation of our role within the cosmos. The implications extend beyond mere academic discourse, influencing fields ranging from physics to metaphysics. Cosmic inflation serves as a pivotal concept in understanding the birth of these infinite universes. It posits that during the first moments after the Big Bang, the universe underwent an exponential expansion. This rapid inflationary period stretched space-time itself, creating the vast cosmic landscape observed today. The initial conditions laid down during this expansion are thought to influence the formation of structures within the universe. Quantum fluctuations, tiny variations in energy levels, emerged during this inflationary epoch. They acted as seeds for the density variations that would later give rise to galaxies, stars, and body. In this model, every pocket of space could potentially evolve into its own universe, each with distinct physical laws and constants. The multiverse emerges as a natural consequence of this inflationary process. Different regions of space may enter their own inflationary phases, leading to diverse realities existing parallel to one another. The implications are profound, suggesting that our universe is just one of an infinite collection, each governed by its unique principles. This framework offers a new perspective on existence itself, challenging traditional notions of reality and our place within it. Afrain Traore proposes a fundamental shift in how particles and forces interact at the most minute scales. Instead of treating particles as point-like entities, it posits that they are composed of tiny vibrating strings. These strings oscillate in multiple dimensions, enabling a vast array of possible configurations. The implications of this theory extend far beyond particle physics, suggesting an intricate network of realities. In this region of theoretical exploration, each unique vibration corresponds to a distinct particle, creating a rich spectrum of physical phenomena. This diversity may lead to the coexistence of multiple universes, each with its own set of physical laws and constants. These alternate realities could differ subtly or dramatically from our own, each shaped by the unique vibrational patterns of their respective strings. As researchers delve deeper into the mathematics of string theory, they uncover potential mechanisms for how these universes might interact. The fabric of space-time itself may be influenced by the dynamics of these strings, allowing for a multiverse that is not merely a theoretical construct, but an integral part of the cosmic framework. This perspective fosters a profound reflection on the nature of existence and the interconnectedness of all realities, inviting contemplation of a vastly more complex universe than previously imagined. Each thread of inquiry leads to deeper understanding, revealing the quiet elegance of the cosmos. The landscape multiverse presents a framework wherein diverse fundamental constants and physical laws manifest across a vast array of universes. This region of theoretical exploration suggests that variations in these constants could lead to an infinite spectrum of realities. Each universe may have distinct properties, influencing the formation of matter, energy, and even the fabric of space-time itself. Cosmological models propose that these differing laws might arise from processes such as cosmic inflation, where rapid expansion creates pockets of space, each with its own set of rules. The implications of this framework are profound. In one universe, gravity could be weaker, allowing for unique structures not seen in our own. In another, the forces of electromagnetism might dominate, leading to radically different forms of matter. In contemplating these possibilities, it becomes apparent that our understanding of existence is merely a fragment of a much larger picture. The various realms might coexist, separated by vast distances or even dimensions imperceptible to human senses. These regions, while not observable, carry profound significance, hinting at the underlying unity of the cosmos despite its apparent diversity. The landscape multiverse invites a reflection on existence itself, suggesting that reality may be more complex and rich than ever imagined. Each potentiality adds a layer to the overall understanding of the universe. Bubble universes emerge as a concept that envisions distinct cosmic regions, each potentially housing its own unique set of physical laws. In this framework, these separate bubbles form within an expansive multiverse, characterized by varying conditions and constants. Each bubble acts independently, expanding and evolving without influence from others, creating a multitude of realities that coexist simultaneously. The boundaries of these bubbles mark the transition between different realms of existence. Inside each bubble, qualities such as gravity, electromagnetic forces, and fundamental particles may differ significantly, leading to diverse manifestations of matter and energy. This variation suggests that life, as known within one bubble, may not exist in another. Governed by entirely different principles, regions of space may remain isolated from one another, their interactions limited to the quantum fluctuations that might occasionally bridge the gaps. Such fluctuations could give rise to new bubbles or alter existing ones, further complicating the structure of the multiverse. The quiet isolation of these cosmic domains contrasts sharply with the interconnectedness often imagined within a singular universe. Understanding bubble universes challenges the conventional notions of reality and existence, prompting the exploration of what truly lies beyond observable limits. Each bubble serves as a reminder of the vastness and complexity that may lie unseen, forever eluding the grasp of current scientific inquiry. Various classifications of multiverses arise from the conceptual frameworks that attempt to categorize the infinite possibilities. The first type, known as the Level 1 multiverse, emerges from the infinite nature of space itself. In this scenario, regions of space beyond our observable universe exist where conditions replicate, leading to the existence of identical copies of our own reality. In contrast, The Level 2 multiverse introduces a more complex structure, rooted in different fundamental laws of physics across various regions. This classification suggests that these distinct universes arise from different configurations of physical constants and parameters, creating realms that can operate under entirely divergent rules. A further distinction can be made with the Level 3 multiverse, which draws from the principles of quantum mechanics. This model posits that every quantum decision generates a branching of realities, resulting in a multitude of outcomes existing concurrently, each representing a different path taken by particles. Finally, the Level 4 multiverse encompasses all mathematical structures. This classification suggests that any conceivable universe defined by mathematical formulations exists, regardless of whether it adheres to physical reality. These frameworks provide a systematic approach to understanding the multiverse, illustrating both the diversity and intricacy of potential realities that may populate the cosmos. Each classification contributes to a broader picture of existence, inviting continued exploration and contemplation. The narration on the stern, the anthropic principle, asserts that the universe appears finely tuned for the emergence of life. It suggests that the fundamental constants and conditions present today are not arbitrary. Rather, they align with the requirements for life as we understand it. This alignment raises profound questions about the nature of reality itself. In this context, the specific values of physical constants, such as the gravitational constant or the strength of electromagnetic forces, play a critical role. Any significant variation in these parameters would preclude the formation of stars, planets, or even atoms, rendering the universe inhospitable to life. The delicate balance found in this region prompts further investigation into the underlying mechanisms that govern these constants. Philosophical implications emerge as well. If numerous universes exist, each with different physical laws and constants, then the observed fine-tuning may simply be a product of selection bias. Our existence in this particular universe, capable of supporting life, suggests that we are among the fortunate few, and the exploration of the anthropic principle leads to deeper inquiries into the nature of existence. Is it merely a coincidence that the universe is so ideally suited for life, or does it hint at a more intricate interplay between consciousness and the cosmos? These reflections continue to shape discussions in both scientific and philosophical realms. The role of dark energy in universe expansion remains a pivotal area of inquiry. Observations indicate that this enigmatic force constitutes approximately 70% of the total energy density of the cosmos. Its presence fundamentally alters the trajectory of cosmic evolution. The accelerated expansion of the universe, first noted in the late 20th century, points to a force acting against gravitational attraction. In this vast expanse, measurements from distant supernovae and cosmic microwave background radiation reveal the influence of dark energy. The fabric of spacetime itself stretches and evolves, hinting at a reality beyond conventional understanding. Current models propose that dark energy exerts a repulsive effect, counteracting the gravitational forces that would otherwise draw galaxies together. Mathematical formulations describe the dynamics of expansion, illustrating how this energy density remains constant throughout time, a characteristic that distinguishes it from other forms of energy. In this context, the cosmological constant serves as a critical parameter, representing the energy density of empty space. Understanding dark energy could hold profound implications for the ultimate fate of the universe. Theories contemplate scenarios ranging from perpetual expansion to eventual cosmic collapse. Each possibility spurs further investigation into the nature of this elusive component, guiding researchers toward a more comprehensive comprehension of cosmic phenomena. Cosmic strings represent one of the more intriguing elements within theoretical physics, hypothesized as one-dimensional topological defects that may have formed during the early moments of the universe. These structures could stretch across vast distances, potentially reaching lengths of billions of light years. Their existence suggests a connection to the fabric of space-time itself, providing insights into the conditions present in the nascent universe. The implications of cosmic strings extend beyond their immediate characteristics. Should they exist, these strings might act as conduits, influencing the formation of universes within a multiverse framework. The gravitational effects produced by such strings could warp space-time, potentially creating pathways or dimensions that lead to alternate realities. This region of theoretical exploration invites contemplation of how different physical laws might manifest in these other realms. Observational evidence remains elusive, yet the mathematical underpinnings supporting cosmic strings align with aspects of string theory and quantum gravity. This connection further blurs the lines between distinct dimensions, suggesting a shared origin for multiple universes. In contemplating the nature of cosmic strings, the interplay of matter, energy, and the very structure of reality is examined, revealing a complex network that may bind multiple universes together in a shared cosmic destiny. The pursuit of understanding continues, each discovery shedding light on the profound and intricate relationship between these phenomena. Exploration of parallel universes permeates popular culture, manifesting in various forms of storytelling. This phenomenon often serves as a vehicle for reflecting on existential questions and the nature of choice. In literature, narratives frequently delve into alternate realities, offering characters the opportunity to confront divergent paths. Such stories examine the consequences of decisions and the myriad possibilities that exist beyond a singular timeline. Film and television further amplify these themes, consistently presenting alternate dimensions as both a plot device and a framework for character development. Iconic representations can be found in series and films, where protagonists navigate through worlds that starkly contrast their original realities. This exploration invites audiences to contemplate the implications of their own choices within the confines of their existence. Video games also engage players by immersing them in environments that allow for manipulation of time and reality. Mechanics often encourage exploration of different outcomes based on player decisions, effectively simulating the multiverse concept. These interactive experiences provide a unique lens through which individuals can engage with the complexity of existence. The recurring motifs across various mediums highlight a cultural fascination with the multiverse. They evoke a sense of wonder, prompting reflections on identity, destiny, and the nature of reality itself. In this way, popular culture continues to shape perceptions of parallel universes, intertwining science with the human experience. Mathematics serves as the fundamental language for articulating the principles underlying multiversal concepts. Equations and models provide the frameworks within which these vast theories operate, allowing for precise calculations and predictions. The realm of string theory exemplifies this, where dimensions beyond the familiar three are expressed through complex mathematical formulations. These abstractions create a scaffold for exploring the nature of reality, suggesting that the universe may contain hidden layers of existence. In this context, the concept of the multiverse emerges from the necessity of reconciling observations with theoretical predictions. Each universe within this expansive framework can be described by unique sets of physical laws, leading to diverse manifestations of matter and energy. The interconnectedness of these realities often hinges on mathematical consistency, revealing relationships that might otherwise remain obscured. The use of probability further enriches this discourse. By employing statistical models, researchers can assess the likelihood of various universes coexisting, each with distinct configurations. This statistical approach introduces a systematic method for examining the implications of different physical constants and their potential variations across multiple realities. Theoretical physics serves as a bridge, connecting the known universe with the myriad possibilities of alternate realities. By employing advanced mathematical frameworks, it enables the exploration of concepts that extend beyond conventional understanding. In this realm of inquiry, ideas such as string theory and quantum mechanics converge, offering a glimpse into the underlying fabric of existence. The interactions of fundamental particles and forces reveal an intricate web, suggesting that variations in physical laws could lead to entirely different manifestations of reality. Tongdays. In this context, dimensions beyond the familiar three become relevant. Extra dimensions, if they exist, may harbor universes with distinct characteristics, governed by unique sets of physical constants. The implications of these theories extend into the nature of time and space, challenging traditional perceptions. Some physicists propose that these alternate realities might coexist with our own, each shaped by different histories and outcomes. The exploration of such possibilities invokes a sense of wonder regarding the multiverse, where every choice can lead to divergent paths. The quest for understanding these realms invites contemplation on the very nature of existence itself, pushing the boundaries of human knowledge. As research progresses, theoretical physics continues to illuminate the profound intricacies of the cosmos, weaving together concepts that could redefine the essence of reality. Observational evidence remains a critical aspect in the quest to detect other universes. Various methodologies are employed to explore the boundaries of reality, each contributing unique insights. Cosmic microwave background radiation serves as a primary focus, offering a glimpse into the remnants of the early universe. Anomalies in this radiation could indicate interactions with neighboring universes, revealing their existence indirectly. Quantum mechanics presents another avenue of exploration. Certain interpretations suggest that fluctuations in quantum fields might hint at the presence of parallel realities. These fluctuations, observable through advanced particle physics experiments, may provide a subtle yet powerful indication of the multiverse. Gravitational waves also hold potential in this search. The ripples in space-time, resulting from colossal cosmic events, can carry information about other dimensions and possibly other universes. When detected, these waves can offer critical clues about the fabric of reality, hinting at phenomena beyond our observable realm. Astronomical observations of large-scale structures in the universe further enhance this pursuit. The distribution of galaxies and galactic clusters might reveal patterns inconsistent with conventional cosmological models, suggesting influences from other universes. Each of these methods contributes to a broader understanding, gradually painting a picture of a reality more complex than previously conceived. This ongoing research may illuminate paths toward confirming the existence of realms beyond our own. Current theories in cosmology suggest a complex framework for understanding the multiverse. These models propose various mechanisms by which multiple universes may arise, each possessing distinct physical laws and constants. One prominent idea stems from the concept of cosmic inflation, which posits that a rapid expansion of space occurred shortly after the Big Bang. This scenario implies that regions of the universe could inflate at different rates, leading to isolated pockets of space-time or separate universes, each with its own unique properties. String theory contributes another dimension to this discourse, suggesting that the fundamental constituents of matter are not point-like particles, but rather one-dimensional strings. In this context, multiple dimensions may exist beyond the familiar four, allowing for an array of universes to emerge with varying dimensions and forces at play. These structures could be interconnected through complex geometries, giving rise to the vast multiversal landscape. The concept of the multiverse also invites philosophical inquiries regarding the nature of existence itself. Each universe could represent a different outcome of cosmic events, leading to a plethora of realities that challenge traditional notions of determinism and individuality. In contemplating these models, the boundaries of reality expand, presenting a universe rich with possibilities. and prompting further exploration of the cosmos and its infinite potential. Quantum entanglement introduces a profound facet to the multiverse theory, suggesting interconnectedness beyond the confines of a singular universe. This phenomenon describes particles that become intertwined in such a way that the state of one immediately influences the state of another, regardless of the distance separating them. Such interactions challenge our conventional understanding of separation in space and time, hinting at the potential for communication between disparate realities. In this context, the implications extend significantly. It raises questions about the nature of causality and the very fabric of existence. If entangled particles can affect each other instantaneously, what might this suggest about parallel universes? The idea that actions in one universe could reverberate across others invites inquiry into the interconnected structure of realities. Entanglement, then, acts as a bridge, linking these realms in ways that remain elusive yet tantalizing. Research into this field of quantum mechanics continues to unveil new layers of complexity, with experiments probing the limits of entanglement and its consequences. Each discovery adds depth to the understanding of how distinct realities might interface. In essence, the delicate dance of these particles embodies a fundamental unity among varied existences, encouraging further investigation into the multiverse and the rules governing its inhabitants. The exploration of these interactions offers a glimpse into a broader understanding of reality itself. Unravel introduces complex dimensions to the multiverse theory, suggesting that alterations in the past can create divergent timelines. Each modification acts as a branching point, leading to the formation of new, distinct realities. This phenomenon raises questions about causality and the nature of existence within these various realms. Theoretical physicists propose that traveling backward in time may lead to a universe where events unfold differently, affecting the trajectory of all subsequent moments. Such alterations illustrate the fluidity of time, revealing it as a construct rather than a rigid framework. The implications of this perspective are profound, as they imply that every decision could spawn a multitude of outcomes, each existing simultaneously in its own universe. These realities, while separate, may also interact through quantum entanglement, allowing for an intricate web of connections across dimensions. In contemplating time travel's place within multiverse theory, it becomes evident that the fabric of reality is more intricate than previously understood. Each timeline carries its own unique history and potential futures, creating an expansive landscape of existence. This exploration invites a re-examination of the universe's nature, suggesting that reality is not merely linear, but a vast continuum of possibilities, each influenced by the choices made within its confines. The implications of such a framework continue to intrigue scientists and philosophers alike. The love of black holes in the multiverse theory presents a captivating area of exploration. These enigmatic entities, formed from the gravitational collapse of massive stars, possess gravitational forces so intense that not even light can escape their grasp. This characteristic has led to speculation regarding their potential as portals to alternate realities. The event horizon, the boundary surrounding a black hole, serves as a point of no return. Once an object crosses this threshold, it is believed to be irrevocably drawn into the singularity at the core. Some theorists postulate that this singularity could act as a bridge to another universe, suggesting that the material consumed by black holes may emerge in a different dimension or reality altogether. In this context, the existence of countless black holes throughout the cosmos becomes significant. Each one could represent a unique gateway, linking disparate realms within an infinite multiverse. Observations of gravitational waves and the behavior of matter near these colossal structures contribute to our understanding of their nature, though much remains shrouded in mystery. The study of black holes not only challenges conventional physics, but also prompts profound questions about existence, reality, and the fabric of the universe itself. It emphasizes the vast unknown that envelops these astronomical phenomena, inviting continued inquiry into their true nature. Simulated realities introduce a fascinating hypothesis within the framework of the multiverse theory. This concept suggests that the universe might not be the singular, physical reality it appears to be, but rather a sophisticated simulation created by advanced intelligences. In this model, the very fabric of existence could be constructed from data and algorithms, leading to an array of possible worlds, each with its own distinct laws and properties. The implications of such a digital multiverse extend beyond mere philosophical speculation. If multiple simulations exist, they may each reflect divergent outcomes based on variances in initial conditions or programmed parameters. The existence of countless realities, existing simultaneously yet independently, raises profound questions about consciousness and identity. This framework encourages a re-examination of what constitutes reality. The boundaries of existence blur, suggesting that perceptions may be mere constructs of an underlying computational process. Researchers in both physics and computer science explore the intersections of these ideas, seeking to uncover whether our own universe displays signs of being a simulation. In this context, the exploration of simulated realities becomes a journey into the fundamental nature of existence itself. It invites contemplation on the possibilities lurking within the digital realm, where the lines between creator and creation dissolve, and where infinite realities may await discovery. The philosophical implications of infinite realities extend beyond mere curiosity, challenging the very foundations of existence. With the notion of countless universes, the nature of choice and consequence evolves significantly. Each decision may give rise to a distinct reality, creating a web of existence that mirrors the complexity of human experience. This framework suggests that every action leads to an alternative path, exploring the depths of free will and determinism. In this context, the value of individual experiences comes into question. If every possibility is realized in some universe, what does it mean to be unique? The exploration of identity shifts, wherein selfhood may be shared across multiple realities. Concurrently, it raises ethical considerations about the impact of choices, as each path diverges into realms with their own consequences and moral landscape. These reflections prompt inquiries into the nature of consciousness itself. If awareness can traverse these infinite realities, the understanding of reality transforms. The concept of the self may become fluid, influenced by experiences across multiple dimensions. Such explorations lead to profound questions about existence and the very fabric of the cosmos, inviting deeper investigation into the nature of reality. This philosophical discourse transcends traditional boundaries, revealing the intricate connections between thought, existence, and the universe. The nature of reality extends into the realms of space, time, and dimensions. Each element interweaves to form the fundamental structure of existence. Space serves as the stage upon which events unfold, while time acts as the dimension in which sequences are ordered, allowing for progression and change. This region is marked by the curvature of space-time, a concept born from the insights of general relativity. The influence of mass and energy on the fabric of the cosmos shapes trajectories and experiences. Dimensions introduce additional layers to this intricate design. The familiar three dimensions of space, length, width, and height, are complemented by time, forming a four-dimensional continuum. Beyond this, theoretical frameworks propose the existence of higher dimensions. These additional realms, often imperceptible to the human experience, could harbor alternate realities or influence the fundamental forces that govern the known universe. In the pursuit of understanding, physicists explore concepts such as string theory, which posits that the fundamental particles of matter are not point-like, but rather one-dimensional strings vibrating within multidimensional spaces. Such proposals challenge perceptions, suggesting a complexity that belies everyday experience. This exploration continues to challenge the limits of human understanding, illuminating the profound nature of existence itself, revealing the intricate interplay between dimensions that perhaps shape not just reality, but the very essence of being. Traditional cosmology presents a universe governed by a singular set of physical laws, a vast expanse where the origins can be traced back to a singular event known as the Big Bang. This perspective maintains a linear progression of time and space, creating a cohesive narrative of cosmic evolution. Structures such as galaxies, stars, and planets emerge through gravitational interactions and the cooling of primordial gases. This framework relies heavily on observable phenomena, anchoring theories to empirical evidence. In contrast, multiverse theory introduces a paradigm where countless universes coexist, each with its own distinct set of physical laws and constants. These alternate realities might emerge from quantum fluctuations, creating a vast ensemble of possibilities. It raises questions about the uniqueness of our universe, suggesting that variations could lead to entirely different outcomes, including the existence of alternate forms of life and divergent cosmic histories. The implications of this theory extend beyond mere speculation. It posits that observed phenomena in our universe may simply be one instance among an infinite array of conditions. Such a perspective offers a more expansive view of existence, inviting consideration of the nature of reality itself. By comparing these frameworks, the philosophical and scientific inquiry surrounding the cosmos deepens, challenging our understanding of the very fabric of the universe. The role of gravity serves as a cornerstone in shaping multiple universes, exerting influence on the structure and behavior of matter across expansive scales. In regions where gravitational forces dominate, the formation of celestial bodies occurs, dictating the orbits of planets around stars and the clustering of galaxies within their respective clusters. Variations in gravitational strength can lead to entirely different physical conditions, allowing for the emergence of diverse universes within the multiverse concept. Differences in gravitational pull can affect the speed of cosmic expansion. In some scenarios, it may lead to the rapid inflation of space, creating regions that isolate themselves from one another. These regions can evolve independently, fostering unique conditions that give rise to distinct sets of physical laws. This divergence results in a multitude of realities, each governed by its specific gravitational dynamic. Observations of gravitational waves, ripples in spacetime caused by cataclysmic events, provide insight into the intricacies of this phenomenon. Detecting such waves opens avenues for understanding how gravitational interactions shape the evolution of both visible and hidden realms within the multiverse. The interplay of gravity not only influences the local phenomena of stars and galaxies, but also resonates through the vast expanse of reality, contributing to the rich complexity of existence itself. Quantum mechanics introduces a fascinating phenomenon known as Hawking radiation, where black holes emit radiation due to quantum effects near the event horizon. This emission results from virtual particle pairs, one of which may escape the gravitational pull, causing a slow loss of mass from the black hole over time. As this process unfolds, it suggests that black holes may not be the eternal prisons once thought, but rather they could eventually evaporate, revealing the dynamic nature of these enigmatic structures. In the context of the multiverse theory, Hawking radiation raises intriguing questions about the fate of information and matter. If black holes can lose their mass and pinwheels their mass and pinfer, this concept invites speculation on how distinct realities might interact or influence one another through these quantum processes. Each universe may experience its unique manifestations of black holes and Hawking radiation, contributing to the diversity of existence. Such interactions, albeit subtle, hint at a network of interconnected realities, each shaped by the fundamental forces and particles governing them. The exploration of these ideas provides insight into the intricate web of existence that permeates the cosmos. This concept suggests that the three-dimensional world may be an intricate projection, a mere illusion arising from two-dimensional information encoded on a distant surface. The implications of such a notion challenge conventional perceptions of reality. It posits that the fundamental nature of existence might be more akin to a holographic image than a solid structure. In this framework, physical objects and events, including those in the cosmos, emerge from the interplay of informational patterns. These patterns reside on a boundary, a cosmic surface that contains all necessary data to recreate the universe's essence. This perspective invites contemplation of the relationship between the observer and the observed, raising questions about the very nature of consciousness and its role in shaping experience. The holographic principle has gained traction in theoretical physics, particularly in string theory and black hole thermodynamics. It provides a coherent explanation for the entropy of black holes, indicating that the information contained within them can be described by the area of their event horizons rather than their volume. These revelations underscore the fragility of perceived reality, illustrating that what is experienced may be only a fraction of a greater, more complex structure. The examination of such theories encourages an understanding of existence that transcends traditional boundaries, offering a glimpse into the profound intricacies of the universe. The nature of consciousness intertwines with multiverse theory, presenting a landscape where multiple realities coexist, each potentially hosting divergent forms of awareness. In this framework, it becomes plausible that every decision creates a branching path, leading to alternate versions of oneself navigating through distinct experiences. This region of thought posits that consciousness is not confined to a single narrative, but instead spread across an infinite spectrum of possibilities. Each reality may embody variations of thought, emotions, and perceptions, suggesting that consciousness itself is fluid and adaptable. This multiplicity allows for the exploration of how awareness can manifest differently across these parallel dimensions. The idea emerges that individual experience is but a glimpse of a larger, interconnected web of consciousness, where thoughts ripple across realities, influencing one another in ways yet to be fully understood. The implications of such a theory challenge the conventional understanding of identity. If multiple selves can exist simultaneously, then the quest for self-awareness expands, inviting contemplation on what it means to truly know oneself. It highlights the potential for growth and transformation inherent in every choice made. As researchers delve deeper into this interplay, insights regarding the essence of thought and existence continue to evolve, pushing the boundaries of both philosophy and science. Quantum fluctuations provide a foundational mechanism for universe creation, existing at the very heart of cosmological theories. These transient variations in energy levels manifest within a vacuum, leading to the formation of virtual particles that momentarily emerge before annihilating. This phenomenon hints at the intricate processes underlying the birth of universes. It is theorized that such fluctuations, when subjected to specific conditions, could instigate inflationary periods, propelling rapid expansion. The vastness of this region is characterized by an almost imperceptible chaos, suggesting that every minuscule fluctuation holds the potential for significant consequences. In an environment dominated by these unpredictable shifts, the fabric of space-time itself may warp, giving rise to diverse realms. Each fluctuation acts as a seed, potentially birthing entire cosmos with unique physical laws and dimensions. The notion of a multiverse emerges from this principle, extending far beyond the confines of the observable universe. It implies that countless variations exist, each shaped by their own quantum events. These realities may coexist, interwoven yet entirely distinct, each with its own narrative of existence. The implications of these findings challenge conventional understanding, compelling researchers to reconsider the nature of reality and the infinite possibilities it encompasses. Such explorations continue to illuminate the profound relationship between quantum mechanics and cosmology, and historical figures have played pivotal roles in the development of multiverse theory. Albert Einstein, known for his theories of relativity, laid foundational principles that prompted inquiries into the nature of space and time. His insights, particularly regarding the curvature of space-time, inspired subsequent thinkers to ponder the implications of multiple dimensions and realities. Following Einstein, Hugh Everett III proposed the many worlds interpretation of quantum mechanics in the 1950s. This radical idea suggested that all possible outcomes of quantum events actually occur across an infinite number of parallel universes. The implications of such a theory expanded the horizons of both physics and philosophy, prompting deeper examination of reality itself.
David Deutsch, a key figure in quantum computing, further advanced these concepts, integrating them into the realm of computational theory. His assertions about the potential of parallel universes to perform calculations have fostered ongoing discussions among scientists and theorists alike. Max Tegmark introduced the notion of a mathematical universe hypothesis, positing that all structures exist independently of their physical manifestations. This notion suggests a layered hierarchy of realities, each governed by distinct mathematical laws. These contributions reflect the evolution of thought surrounding the multiverse, highlighting a continuous quest for understanding the complexities of existence within this vast cosmos. The debate surrounding the testability of multiple universes remains a significant topic within theoretical physics. Some argue that the concept of parallel realities eludes empirical verification, as these realms lie outside observable phenomena. This difficulty in measurement raises questions about the scientific validity of the multiverse hypothesis. Various scholars propose that the existence of other universes may manifest through indirect signatures, such as cosmic background radiation anomalies or gravitational waves. These potential markers could offer glimpses into realms beyond direct observation. Other experts maintain that without definitive evidence, the multiverse theory cannot be classified as a scientific theory in the traditional sense. The implications of this perspective suggest that many aspects of quantum mechanics may not conform to the familiar paradigms of scientific inquiry. The ongoing discourse reflects the tension between philosophical interpretations of reality and the empirical foundations of scientific practice. Some researchers explore the implications of string theory, which posits additional dimensions and may provide a framework for understanding the multiverse. This pursuit engages with notions of inflationary cosmology, wherein rapid expansion after the Big Bang could produce myriad universes. The exploration of these concepts contributes to a deeper comprehension of the cosmos, inviting further inquiry into the nature of existence. The cosmic microwave background radiation serves as a relic from the universe's infancy, presenting a snapshot of its early moments. This faint afterglow, emanating from every direction, embodies the residual heat from the Big Bang, providing crucial insights into the conditions prevailing shortly after the universe's formation. Its uniformity and slight variations reveal vital details about the density fluctuations that eventually led to the formation of galaxies and larger structures. Measuring this radiation has allowed scientists to glean essential information about the age, composition, and expansion rate of the universe. The precise temperature of approximately 2.7 degrees Kelvin indicates a cooling that has occurred over billions of years, marking the transition from an intensely hot state to the vast cosmos observed today. This cooling has paved the way for the formation of matter, stars, and galaxies. Analysis of the cosmic microwave background aids in understanding fundamental cosmological principles, including the inflationary model, which proposes a rapid expansion of the universe immediately after the Big Bang. The intricacies of these fluctuations have been meticulously mapped by satellites, revealing patterns that hint at the underlying fabric of space-time itself. This exploration continues to challenge and refine existing theories, reinforcing the notion that the universe is a dynamic entity, constantly evolving and revealing its mysteries. The multiverse concept suggests an expansive realm beyond observable limits, where countless universes exist, each with distinct physical laws and constants. This region offers a perspective on the fate of our universe, hinting at possibilities beyond the singular path it currently follows. It invites contemplation of scenarios where alternate realities unfold under different conditions, leading to varied outcomes for cosmic evolution. The eventual fate of this universe may align with theories such as the Big Freeze, where expansion continues indefinitely, leaving galaxies isolated in an ever-cooling void. In contrast, some universes might experience a big crunch, collapsing into singularity, or undergo a big rip, where forces of dark energy eventually tear matter apart. Each outcome reverberates through the multiverse, suggesting that while our reality may face a specific destiny, others may thrive under different circumstances. The implications of such a framework extend into fundamental questions about existence and the nature of reality itself. If these realities coexist, the exploration of quantum mechanics reveals how probability and uncertainty influence outcomes. Through this lens, the multiverse serves not only as a theoretical construct, but also as a profound inquiry into the nature of creation, existence, and the ultimate fate of cosmic phenomena, shaping our understanding of the universe's very fabric. Philosophical challenges arise when considering the implications of the multiverse on determinism and free will. Within this framework, every choice made could potentially spawn a new reality, leading to the notion that all possible outcomes coexist in an infinite landscape. This idea raises questions about the nature of agency and responsibility. If every decision branches into a separate universe, to what extent do individual actions influence the broader cosmos? In this context, determinism encounters a significant challenge. Traditional views posit that events are predetermined by preceding causes, leaving little room for the concept of choice. The multiverse complicates this narrative, suggesting that while certain paths may be determined, countless alternatives exist simultaneously. Each moment of decision could be viewed as a crossroads, where the act of choosing creates distinct realities, each unfolding its consequences. The implications stretch into ethics and accountability. If an individual exists in a universe where every possible choice has been made, what does that mean for moral responsibility? This region of thought invites deep reflection on the human condition, the essence of choice, and the nature of existence itself. As these ideas continue to evolve, the inquiry into free will and determinism within the multiverse remains a rich field for exploration, prompting ongoing debate among philosophers, scientists, and thinkers alike. Thought experiments serve as a powerful tool in examining alternative realities, allowing for the exploration of possibilities beyond current understanding. They create scenarios where the boundaries of existence can be tested, revealing the implications of different choices made across countless timelines. In this vast expanse of potential outcomes, each decision branches into new paths, demonstrating the fluidity of fate and circumstance. Consider the implications of a single choice leading to divergent realities. In one instance, an individual may pursue a particular career, while in another, the same individual may choose a completely different path, leading to contrasting lives. These variations highlight the interconnectedness of decisions and their profound effects on one's trajectory. Another thought experiment involves the concept of parallel universes, where numerous versions of oneself exist simultaneously. Each version experiences its own unique set of challenges and triumphs, offering insights into the nature of identity and consciousness. The exploration of these realities raises questions about the self. Is it defined by choices, Or is there a core essence that transcends individual experiences? Engaging with these ideas enables a deeper understanding of existence, enriching the discourse surrounding the multiverse. Such inquiries illuminate the intricate web of reality and the profound implications of choice and consequence on a cosmic scale. This exploration of symmetry reveals its foundational role in multiversal physics. In various theoretical frameworks, symmetry acts as a guiding principle, shaping the laws that govern each universe. These structures create a balance, providing insights into the behavior of particles and forces. It is through these symmetrical patterns that fundamental interactions emerge, leading to diverse physical phenomena across different realities. The concept of symmetry extends beyond mere mathematics. It embodies a deeper truth about the nature of existence itself. In some universes, symmetries may lead to uniform laws of physics, while in others, slight variations result in vastly different outcomes. This divergence illustrates the potential for infinite forms of matter and energy, each existing within its distinct realm, yet all bound by the same underlying principles. Investigations into these symmetrical properties have prompted scientists to consider the implications of broken symmetries. Instances where symmetry is disrupted can lead to unexpected behaviors, birthing new particles or forces. Such disruptions might explain the emergence of complexity within seemingly simple systems, contributing to the richness observed in our universe. The impact of multiverse theory reshapes fundamental scientific paradigms. This concept posits the existence of countless universes, each with distinct physical laws and constants. It challenges the traditional notion that our universe is the singular reality, inviting scholars to reconsider the very fabric of existence. The implications extend beyond cosmology, influencing fields such as quantum mechanics and philosophy. In quantum mechanics, interpretations like the many worlds interpretation suggest that every quantum event branches into separate realities. Each decision or interaction creates a divergence, yielding a multitude of outcomes across different universes. This perspective shifts the understanding of probability, offering a more nuanced view of determinism and randomness. Philosophically, multiverse theory confronts existential questions regarding life and consciousness. The existence of infinite realities opens avenues for exploring the nature of self and identity. If every possible version of reality unfolds simultaneously, the significance of individual experiences is re-examined. The implications for ethics and morality also arise, as actions in one universe may resonate through countless others. Scientific discourse adapts to accommodate these radical ideas, fostering interdisciplinary exploration. Researchers delve into the mathematical frameworks that underpin multiverse models, striving for empirical validation. In this evolving landscape, the quest for knowledge continues, driven by curiosity and the wonder of what lies beyond the observable. Exploration into the multiverse suggests that our universe is but one of many, each potentially governed by distinct physical laws and constants. This concept unfolds intriguing possibilities, positing that every decision creates divergent outcomes, resulting in an infinite number of realities. Within this framework, computational theory emerges as a vital tool, seeking to understand and simulate these vast realms. Through advanced algorithms and powerful computing technologies, researchers attempt to model these alternate universes, examining the interplay between quantum mechanics and information theory. This exploration reveals how complex systems might evolve under varying conditions, offering insights into fundamental questions about existence and reality itself. In these simulations, parameters can be adjusted to reflect different laws of physics, enabling a deeper understanding of how various universes might operate.
As calculations progress, they not only enhance comprehension of our universe, but also illuminate the potential for others. where differing constants could yield entirely different phenomena. The implications of this research extend into philosophical domains, challenging traditional views of reality and existence. Each computed universe serves as a reflection of theoretical possibilities, inviting contemplation of the nature of choice, chance, and determinism. This intersection of computational theory and the multiverse presents a new frontier in humanity's quest for understanding its place within an expansive and complex cosmos. Exploring the ethical dimensions of infinite realities reveals profound questions about existence and responsibility. Each potential universe within the multiverse embodies unique scenarios, posing dilemmas that challenge traditional moral frameworks. The implications of choices made in one reality ripple through others, creating a complex web of consequences that extends far beyond individual actions. This complexity necessitates a re-evaluation of free will and determinism. In a landscape where every decision spawns alternative outcomes, the accountability of beings becomes ambiguous. They may find themselves grappling with the knowledge that their actions could manifest differently across infinite realms, leading to varying degrees of suffering or joy. The existence of alternate realities raises concerns about the value of life itself. If every potential outcome exists simultaneously, then the significance of individual experiences may be diminished. This perception can lead to existential despair or, conversely, a sense of liberation. The awareness of infinite possibilities can inspire both creativity and nihilism, shaping how beings perceive their roles within this intricate structure. These ethical inquiries extend to the implications of technology designed to navigate or even manipulate these realities. Questions about consent, autonomy, and the potential for exploitation emerge, underscoring the necessity for a thoughtful approach to this burgeoning field of exploration. The task of understanding the moral landscape of infinite realities is as vast as the multiverse itself. These realities beckon exploration of life beyond familiar confines. In countless realms, conditions may vary dramatically, ranging from those similar to Earth to environments entirely alien. Each universe could possess unique physical laws, yielding diverse forms of existence. In some, life might thrive in extreme temperatures, while in others it may emerge in environments dominated by gaseous compositions. Astrobiologists theorize that the building blocks of life, such as amino acids and simple organic molecules, could form under varying conditions, potentially leading to evolutionary processes distinct from terrestrial patterns. This possibility extends to intelligent life, which might evolve with distinct physiological and cognitive traits shaped by their unique surroundings. These environments may host ecosystems founded on different energy sources, such as sulfur-based compounds or even electromagnetic fields. The implications of such diversity challenge the very definitions of life, expanding the framework within which scientists operate. Though direct evidence remains elusive, the exploration of these alternate realities inspires innovations in scientific thought and technology. Discovering the potential for life in these universes can reshape humanity's understanding of existence, intelligence, and our place within the cosmic expanse. Such inquiries invite a re-examination of what it means to be alive in an infinite spectrum of possibilities. The quest continues, probing the unknown. Mathematics provides a foundation for exploring the concept of infinity through Cantor's set theory. This framework introduces the idea of different sizes of infinity, challenging conventional understanding. In this region of thought, a set can contain an infinite number of elements, yet some infinite sets can be larger than others. The integers, for instance, form a countably infinite set, allowing them to be matched with natural numbers in a one-to-one correspondence. Contrastingly, the set of real numbers is uncountably infinite, demonstrating a higher order of infinity. Cantor's diagonal argument illustrates this distinction by showing that it is impossible to list all real numbers in a complete sequence. This finding implies that within the infinite realm, there exist unbounded possibilities, each representing a unique reality. The implications extend beyond mathematics, influencing philosophical discussions regarding existence and parallel universes. Each infinite set can be perceived as a universe where variations exist within the same framework. This perspective invites contemplation about the nature of reality, suggesting a vast expanse of unobserved dimensions. Such revelations contribute to ongoing debates in cosmology and theoretical physics, creating a bridge between the abstract and the tangible. The exploration of infinity not only enriches mathematical theory, but also deepens the understanding of the universe's potential complexity. Current research trends in multiverse studies reflect a growing interest in diverse theoretical frameworks. These frameworks include string theory, which suggests that fundamental particles may be one-dimensional strings rather than point-like entities, leading to various dimensional configurations. This concept introduces the possibility of multiple universes, each with distinct physical laws and constants. Within this model, different regions can cease inflation at different times, potentially creating isolated bubbles. Each bubble could develop into its own universe, characterized by unique properties and conditions. Quantum mechanics also plays a crucial role in multiverse discussions, particularly through the many worlds interpretation. This perspective posits that every quantum event branches into multiple outcomes, leading to the existence of parallel realities. This interpretation raises profound questions about determinism and the nature of choice. Research continues to examine the implications of these theories, often employing advanced mathematical models and computational simulations. Observational evidence remains limited, yet scientists explore indirect signs, such as cosmic background radiation patterns, that may hint at the existence of neighboring universes. This ongoing inquiry challenges existing paradigms and invites a re-evaluation of the universe's structure, stretching the boundaries of human understanding. The role of quantum computing in multiversal exploration emerges as a pivotal element in deciphering complex datasets. This technology harnesses the peculiar properties of quantum bits, or qubits, enabling computations that far exceed classical capabilities. By processing vast amounts of information simultaneously, it opens pathways to simulate and analyze theoretical multiverse scenarios with unprecedented precision. Connections arise between quantum principles and the multiverse theory itself, suggesting that every decision may spawn alternate realities. In this context, quantum computing serves as a crucial tool for modeling these branching pathways, allowing researchers to visualize and explore possible outcomes of quantum events. The intricacies of entanglement and superposition facilitate a deeper understanding of these parallel dimensions, revealing potential patterns and correlations that remain hidden within traditional computational frameworks. Each calculation, each simulation, contributes to a broader comprehension of reality's structure and the interplay of various universes. Insights gleaned from this advanced technology lead to implications not only for theoretical physics but also for cosmology and philosophy. As researchers delve deeper into the multiverse's vastness, the ability to manipulate complex quantum systems positions humanity at the cusp of a new era in exploration. These advancements prompt a re-evaluation of existence, emphasizing the intricate web of possibilities that define our understanding of everything that is. Each universe may possess its own narrative, shaped by unique events and conditions. This region of thought invites exploration into the myriad tales woven through infinite realities. In some realms, the laws of physics may differ, leading to alternative outcomes and unprecedented phenomena. The nature of time could stretch or compress, resulting in variations of history that diverge at critical moments. In one instance, a small decision might alter the course of civilization, while in another, the trajectory remains unchanged. These divergent paths illustrate the profound influence of choice and chance. Cultural narratives evolve within each universe, reflecting the values, struggles, and triumphs of their inhabitants. Societies may arise that mirror our own yet differ in fundamental ways, allowing for an expansive understanding of what it means to exist. The exploration of these stories reveals the interconnectedness of all things, suggesting that every experience contributes to a larger whole. The echoes of past choices resonate through time, creating a landscape rich with meaning. Each tale serves as a fragment of a broader narrative, offering insights into the nature of reality itself. In this vast multiverse, the exploration of existence unfolds like a book with endless chapters, each revealing new dimensions of thought and understanding. The implications of multiverse theory extend deeply into the realm of modern philosophy, prompting questions that challenge foundational concepts of existence and reality. This framework suggests the existence of countless parallel realities, each diverging at critical junctures from the one we inhabit. Such a notion invites profound inquiries into free will and determinism. If every choice creates a new universe, the implications for moral responsibility and ethical frameworks are substantial. Philosophers grapple with the nature of identity across these infinite possibilities. The continuity of the self becomes a complex puzzle when considering alternate versions of individuals existing simultaneously. This region of thought evokes debates surrounding personal identity. What does it mean to be you if multiple iterations exist in divergent realities? The influence of this theory extends to metaphysical discussions regarding the nature of truth and knowledge. Each reality may embody differing truths, leading to a re-evaluation of epistemological frameworks. This perspective challenges the traditional notion of a single, objective reality, suggesting instead a more fluid understanding of existence. In examining these concepts, the philosophical landscape shifts, revealing new pathways for inquiry. The multiverse theory not only enriches scientific discourse, but also enhances the depth of philosophical exploration, inviting a reconsideration of the very fabric of reality itself. The quest for definitive evidence remains fraught with complexity. Various approaches have been proposed, yet each encounters significant challenges. The nature of these alternate realities defies direct observation, often relegating the search to indirect implications drawn from theoretical frameworks. Quantum mechanics, with its probabilistic nature, suggests multiple outcomes exist simultaneously. This gives rise to interpretations that hint at parallel universes, yet none provide concrete proof. An instrumentation capable of detecting such realms is currently limited. Advanced technologies, such as high-energy particle colliders and sophisticated telescopes, are developed to probe the fundamental components of the universe. These tools investigate minute particles and cosmic phenomena, yet the evidence required to substantiate the multiverse remains elusive. Many theories hinge on mathematical extrapolations rather than empirical data, reinforcing an ongoing debate within the scientific community. The implications of the multiverse theory also stir philosophical inquiries, questioning the principles of causality and existence. These discussions illuminate the tension between observable phenomena and the vast possibilities that may lie beyond sensory perception. The implications challenge the boundaries of current understanding, urging a re-evaluation of what constitutes evidence. Scientific rigor demands verification. The pursuit continues as researchers explore concepts that could one day bridge the gap between theory and evidence, potentially reshaping the comprehension of existence itself. The implications of the multiverse theory extend beyond the realms of physics, prompting profound reflections on religious and spiritual beliefs. This framework suggests that an infinite number of universes may exist, each with distinct realities and possibilities, leading to questions about the nature of creation and the divine. Traditional narratives of a singular origin are challenged by the idea that countless variations of existence could coexist simultaneously, influencing theological interpretations on creation. In this expansive view, the concept of a singular deity may evolve, leading to a more pluralistic understanding of divinity. The presence of numerous universes may suggest that multiple interpretations of God are equally valid, fostering a deeper acceptance of diverse spiritual practices. This region of thought encourages dialogue among various belief systems, as the existence of parallel realities could be perceived as an affirmation of differing paths to truth. Philosophically, it raises inquiries about free will and predestination. If every decision branches into a new universe, the nature of choice takes on new dimensions. This understanding challenges adherents to grapple with the purpose of individual lives within an infinite continuum. In the face of such vastness, humanity's search for meaning persists, intertwined with the possibility that existence may be more intricate than previously conceived, inviting a re-evaluation of belief across cultures and disciplines. Artistic expression and scientific inquiry often occupy separate realms, yet the intersection of these domains offers profound insights into the nature of reality. This region of inquiry reveals how creative perspectives can enhance understanding of complex scientific concepts. Visual art, for instance, can translate abstract theories into tangible experiences, making the enigmatic nature of phenomena like dark matter and quantum entanglement more accessible. Literature and poetry explore existential themes, encapsulating the essence of human experience in the context of cosmic enormity. Such works provoke thought, challenging individuals to consider their place within the broader universe. In this way, the arts foster a deeper emotional and philosophical engagement with scientific explorations. Collaboration between artists and scientists cultivates innovative approaches to problem solving. These partnerships can generate visualizations that illuminate intricate datasets, making scientific information more relatable. They can also inspire new hypotheses born from the creative process, merging intuition with empirical methods. Educational frameworks increasingly emphasize interdisciplinary studies, recognizing that knowledge is enriched when diverse fields converge. This blending of disciplines cultivates a holistic understanding of the universe, encouraging learners to appreciate the myriad ways in which humanity interprets existence. In this shared pursuit, the boundaries between art and science blur, revealing a more comprehensive view of reality's complexity. The implications of multiverse theory extend beyond mere philosophical musings, reaching into the realm of artificial intelligence. This concept suggests that within countless parallel universes, myriad possibilities exist for the development and evolution of intelligent systems. Each iteration of artificial intelligence may encounter unique challenges and opportunities, shaping its capabilities and ethical frameworks in distinct ways. In this expanse of realities, one can envision AI systems that evolve under radically different conditions, influenced by varying societal norms or technological advancements. These systems might exhibit divergent behaviors, some aligned with human values while others could diverge significantly. Such variations provoke questions regarding the nature of intelligence itself and whether it can genuinely emulate human-like understanding or morality. Exploring these dimensions invites contemplation of machine learning techniques. Each AI could harness experiences from its respective universe, applying lessons learned to refine its algorithms. This adaptation might lead to an unprecedented sophistication in problem-solving and decision-making. The multiverse also raises ethical dilemmas. If each AI exists within its own reality, the responsibility for its actions becomes increasingly complex. The decisions made by an AI may ripple through its universe, impacting countless lives in ways not immediately apparent. These considerations reveal the vast interconnectedness of intelligence, existence, and choice within the fabric of the multiverse. The future of multiverse research offers a landscape rich with potential discoveries. As theoretical frameworks evolve, An increased understanding of quantum mechanics could provide insights into the nature of these countless realities. Current endeavors aim to establish connections between various dimensions, exploring how they may interact. Such investigations may lead to methodologies that allow for the testing of multiverse theories through experimental data. In this evolving field, researchers speculate on the existence of parallel universes, each with its own unique set of physical constants and laws. With advancements in technology, instruments designed to probe deeper into cosmic phenomena could unveil evidence supporting or refuting these concepts. The notion of a multiverse encourages the examination of cosmic inflation, black holes, and even the phenomena surrounding dark energy, suggesting that new discoveries could emerge from unexpected areas of research. The implications of multiverse theories extend beyond the realm of physics, inviting interdisciplinary dialogue among philosophers and cosmologists. Questions of existence and consciousness may be revisited, with each discovery igniting further inquiry into the nature of reality itself. As exploration continues, the quest for understanding may lead to a more profound appreciation of the complexities inherent in existence, shaping a future that transcends current scientific paradigms. The relationship between space-time curvature and cosmic models serves as a fundamental pillar in the understanding of the universe. This phenomenon, rooted in Einstein's theory of general relativity, posits that massive objects can warp the fabric of space-time around them. Such distortions influence the trajectories of celestial bodies, dictating their paths through the cosmos. Curvature manifests itself in various forms, from the gentle arcs of planetary orbits to the more dramatic warping exhibited near black holes. This region, characterized by intense gravitational fields, starkly illustrates how extreme mass can create profound bends in space-time. Even light, which travels at remarkable speeds, is not immune to these curvatures, bending around dense objects and leading to phenomena such as gravitational lensing. The implications of this curvature extend beyond mere observation. They inform cosmic models that attempt to describe the large-scale structure of the universe, including the distribution of galaxies, the expansion rate, and the behavior of dark matter. Understanding these aspects requires a careful analysis of the interplay between gravity and the geometry of space-time. Observations across various wavelengths contribute to this body of knowledge, revealing the underlying patterns and dynamics of the universe. Each finding serves to refine existing theories, allowing for a deeper comprehension of this intricate cosmic framework. For renew and await storage retains a layer of complexity to metaphysical discussions, challenging traditional notions of reality. At the subatomic level, particles exhibit behaviors that defy classical physics, leading to perplexing implications for the understanding of existence. This region is characterized by uncertainty. Particles can exist in multiple states simultaneously, a phenomenon known as superposition. Such behavior raises questions about the nature of reality itself. Entanglement further complicates this intricate web, where particles become interconnected regardless of distance. Changes to one particle instantaneously affect its counterpart, suggesting a fundamental link that transcends conventional spatial boundaries. These principles invite philosophical inquiries into the nature of consciousness, perception, and the fundamental structure of reality. The implications extend beyond theoretical physics, influencing areas such as metaphysics and even spirituality. Concepts once relegated to philosophical debate now find resonance in scientific inquiry. This relationship prompts re-evaluation of deterministic views, opening pathways to interpretations that embrace a more fluid understanding of existence. As researchers delve deeper into these quantum phenomena, they uncover a reality that appears to be less fixed and more dynamic, challenging the very fabric of what is perceived as the universe. The exploration of these ideas continues to unfold, shaping the contours of both science and philosophy in profound ways. The multiverse concept invites scrutiny of the very framework that underpins scientific theories. It suggests an expansive reality where countless universes exist, each with distinct physical laws and constants. This region is not merely theoretical. It prompts a re-evaluation of how scientific models are constructed and validated. Within these myriad possibilities, the boundaries of empirical evidence shift, challenging traditional notions of testability. In this landscape, the structure of scientific theories becomes fluid. They are no longer confined to in some dimensions. Paths are predetermined, where events unfold according to a grand design, leaving little room for deviation. This structure influences the behavior of individuals, shaping their perceptions and decisions within the confines of fate. In contrast, alternate realities may exhibit a fluidity that allows for spontaneity and free will, where outcomes hinge upon personal agency. Time itself can differ significantly from one reality to the next, affecting how destiny is perceived. In certain variations, linear progression is replaced by circular or even simultaneous timelines, challenging the conventional understanding of cause and effect. Each choice taken or avoided reverberates throughout the multiverse, creating a complex web of interconnected narratives. This exploration of destiny across multiple realities raises profound questions about identity and purpose. In some instances, individuals may encounter alternate versions of themselves, each shaped by divergent choices and circumstances. These encounters offer not only insight but also a reflection of the myriad potentialities that exist within their consciousness. The interplay between fate and free will emerges as a central theme, inviting contemplation on the significance of choices, the nature of existence, and the intricate dance of possibilities that unfolds across the multiverse. Patterns emerge, revealing a profound interconnectedness among universes. Each realm, while distinct, shares fundamental laws governing reality. The fabric of existence weaves through dimensions, suggesting a shared origin or a fundamental structure that binds them. This unity hints at a singular, overarching framework that encapsulates the multiverse. Connections can be observed through phenomena such as quantum entanglement, where particles across these realms influence one another, regardless of distance. This suggests an underlying network facilitating communication between realities, transcending the perceived boundaries of space and time. The implications of this interconnectedness extend into realms of theoretical physics, where researchers explore the potential for travel or interaction across dimensions. In this context, every action taken in one universe reverberates through others, generating ripples of consequences that transcend local events. The exploration of alternate realities highlights the variable nature of constants and laws, revealing how slight divergences can lead to vastly different outcomes. The pursuit of a unified theory becomes more pressing as discoveries continue to unfold. Each breakthrough offers glimpses into a more comprehensive understanding of existence itself. The quest to map these connections invites deeper inquiry into the nature of reality, challenging the limits of human perception and comprehension. A vast network awaits exploration, each thread an invitation into new realms of understanding. This intricate framework reshapes perceptions of reality and existence. The multiverse theory posits that countless universes coexist, each with distinct physical laws and properties. This concept invites contemplation of existence beyond the confines of a singular reality. It fosters a sense of humility, reminding humanity that their universe is but one of many, each with its own narrative and potential. In this expansive view, the implications for human perspective are profound. It challenges the notion of a centralized existence, suggesting that experiences and choices ripple across various dimensions. Decisions made in one universe may lead to divergent outcomes in another. This recognition of infinite possibilities can alter motivations, prompting individuals to consider the significance of their actions in a broader context. The theory also encourages a deeper inquiry into the nature of consciousness. If multiple realities exist, the essence of self may transcend the limitations of a single life, intertwining with myriad forms of existence. This line of thinking nurtures curiosity about the universe and its underlying principles, fostering a desire for exploration and understanding. As humanity delves into these philosophical inquiries, the horizon expands, revealing not just the mechanics of existence but also the emotional and existential implications of living within a multiverse, where every choice and thought may resonate across endless realities. The recognition of infinite choices leads to profound philosophical contemplation regarding free will and determinism. In this framework, each decision branches into a multitude of outcomes, creating parallel dimensions where alternate versions of oneself exist, each navigating different paths. This realization poses questions about the nature of identity. If countless iterations of an individual inhabit various realities, what constitutes the essence of self? Within these realms, the weight of decisions can feel both liberating and burdensome. Each choice carries the potential for divergent consequences, affecting not only the individual, but also the interconnected web of existence spanning across dimensions. The implications extend into morality, as actions resonate through countless variations, inviting scrutiny on ethical frameworks. This scenario fosters a nuanced understanding of responsibility, where the outcomes of choices ripple through infinite possibilities. The experience of loss, joy, and regret manifests differently in each reality, prompting reflections on the nature of success and failure. Emotions become fragmented as the burdens of choices stretch across dimensions, influencing countless lives. Navigating this philosophical landscape raises vital inquiries about purpose and meaning. In a multiverse, does significance dissipate among endless repetitions, or does it deepen, suggesting that within each reality, every decision shapes the unfolding narrative of existence? Information acts as the cornerstone of comprehension in the multiverse framework. It permeates every facet of these infinite realities, shaping interactions and outcomes. Each piece of information, whether a choice made or a chance encounter, resonates through the myriad universes, influencing trajectories in subtle yet profound ways. This nuanced interplay creates a complex web where knowledge is not merely a tool, but rather a vital force guiding the course of existence. Within this vast expanse, the nature of reality itself becomes a reflection of the information held within it. Different outcomes emerge from varying data processes, leading to a rich variety of experiences across alternate dimensions. The way that information is perceived and processed varies significantly from one reality to another, giving rise to distinct cultures, technologies, and philosophies. In this realm, the flow of information is unceasing, fostering an intricate dialogue among realities. Each decision made in one universe can ripple across others, resulting in an interconnectedness that challenges the notion of isolation. Understanding these dynamics is essential for grasping the broader implications of existence. It reveals a landscape where knowledge is fluid and realities are shaped by the collective understanding inherent within them, allowing for an exploration of what could be, should be, and what has been. This exploration encourages a re-evaluation of established frameworks, urging scientists to consider the implications of interconnected realities. The future of cosmology may depend on these new paradigms, urging a departure from traditional models that rely heavily on observable phenomena. Innovative theories now emerge, weaving together quantum mechanics and relativity, suggesting that what lies beyond the observable universe may hold answers to fundamental questions. Researchers propose that each universe within this expansive multiverse possesses unique physical laws and constants, influencing the very essence of its existence. This notion leads to the possibility of universes where the conditions for life differ dramatically from those of the known universe. Insights gleaned from theoretical physics and advanced simulations may illuminate these alternate realms, providing glimpses into their structure and behavior. Understanding these divergent realities could yield profound implications for the nature of existence itself. The interplay of gravity, dark energy, and quantum fluctuations may reveal a complex web that binds these universes, allowing for deeper investigation into the fabric of reality. As this field advances, new methodologies arise, incorporating observational data from cosmic background radiation and galaxy formations. Shifting perspectives on time, space, and dimensionality may lead to breakthroughs that redefine our comprehension of the universe and our place within it. The convergence of scientific exploration and speculative fiction unveils a realm where imagination fuels inquiry. This intersection inspires innovative thought, propelling scientists to consider possibilities beyond established norms. Concepts once relegated to the pages of fiction are increasingly being examined through empirical lenses, urging theorists to explore the implications of multidimensional existence. The fabric of reality, woven with threads of quantum mechanics and cosmological phenomena, suggests that the boundaries of our understanding may be far more fluid than previously assumed. In this environment, theories about parallel universes gain traction, suggesting that each decision spawns alternate realities. This region of inquiry is not merely abstract, it challenges the very essence of causality and fate. The exploration of these ideas invites rigorous questioning and experimentation, pushing the limits of conventional physics. Researchers are delving into the foundational principles of existence, seeking to uncover the underpinnings of time and its interaction with space. Such investigations necessitate a profound shift in perception, contemplating realms that may harbor life forms and civilizations beyond our reach. While the implications are vast, each discovery serves to deepen the understanding of the cosmos, revealing the intricate complexities woven into the nature of reality itself. This journey through the multiverse not only expands scientific boundaries, but also enriches the philosophical discourse about existence. The concept of parallel lives introduces a profound dimension to the multiverse. Each decision made branches into a new reality, creating an intricate web of possibilities where countless variations of existence unfold. In this expanse, an individual could experience an infinite array of outcomes based on the choices they encounter, the paths they decide to tread, and the circumstances that arise. This region of thought encourages reflection on the nature of identity. It raises questions about the self across different realities. Do these alternate versions share the same essence, or are they fundamentally distinct beings shaped by their particular experiences? The interplay of fate and free will becomes a focal point, as it suggests that every moment is a nexus of potential, branching into realms previously unimagined. Interactions among these realities could lead to fascinating implications. Theoretical physics posits that these alternate dimensions might interact subtly, influencing one another in ways that remain largely undetectable. Observing these interactions could provide insights into the fundamental laws governing existence, revealing the delicate balance between chaos and order. Understanding the existence of other universes brings forth significant epistemological challenges. The nature of knowledge itself becomes complex when contemplating realms beyond observable reality, limited by the confines of current scientific methods. These inquiries often skirt the edges of empirical validation. It raises questions about what can truly be known if these universes operate under different physical laws or realities. The implications of the multiverse theory require a re-evaluation of the scientific method. Traditional approaches rely heavily on observation and repeatability, yet many proposed universes remain inaccessible. These realms may exist outside the observable horizons, making direct study impossible. Consequently, the knowledge acquired becomes speculative, dependent on mathematical frameworks and theoretical models rather than empirical evidence. Philosophical inquiries emerge as well, questioning the criteria for knowledge in such a vast landscape. If existence cannot be verified through observation, are these alternate realities any more than abstract constructs? Herein lies the conundrum. The more one explores the boundaries of understanding, the more nebulous the distinction between knowledge and belief becomes. Engaging with these questions shapes a deeper comprehension of our universe while simultaneously expanding the horizons of what it means to know. It invites contemplation on the nature of reality itself, emphasizing that knowledge may be as infinite and multifaceted as the universes it seeks to uncover. Theoretical models serve as frameworks through which the complexity of reality can be examined and understood. These constructs enable scientists to explore concepts that transcend immediate empirical observation. In the context of the multiverse theory, they provide a means to conceptualize the existence of numerous, potentially infinite, parallel realities. Each model posits different mechanisms, suggesting diverse origins and configurations of these universes. Mathematical formulations play a crucial role, allowing for predictions that can be tested against observable phenomena. Quantum mechanics, for instance, introduces ideas about probability and uncertainty, leading to interpretations that support the multiverse hypothesis. This region of thought challenges traditional notions of causality and determinism, presenting a landscape where outcomes can branch into distinct realities. The implications of these models extend beyond theoretical physics, influencing philosophy and cosmology. They compel a re-evaluation of existence and the fundamental laws that govern it. The beauty of theoretical constructs lies in their ability to provoke exploration and inquiry, leading to advancements in our comprehension of the cosmos. In their pursuit of understanding, scientists grapple with the limitations of current technology and measurement. Theoretical models bridge this gap, providing insight into realms that remain elusive, nurturing the ongoing quest for knowledge in an ever-expanding universe. Through these frameworks, humanity inches closer to grasping the intricate nature of reality itself. Welt and literature serve as profound vessels for exploring the concept of the multiverse. Through imaginative narratives and visual interpretations, creators delve into the vastness of infinite realities. This dynamic interplay between creativity and theoretical physics reflects humanity's quest to understand existence beyond the observable universe. In literature, tales of parallel worlds invite readers to reconsider their understanding of destiny and choice. Characters traverse alternate dimensions, encountering versions of themselves shaped by different decisions. These narratives often highlight the fragility of perceived reality, suggesting that even the slightest divergence can yield entirely new outcomes. The written word transforms abstract theories into relatable experiences, fostering a deeper connection with the complexities of existence. Visual art echoes these themes, using vivid imagery to represent the multiverse's boundless possibilities. Artists conjure landscapes that defy conventional physics, merging elements from disparate realms into cohesive compositions. Surreal scenes evoke a sense of wonder while prompting contemplation of the unseen forces that govern reality. These creative expressions resonate with audiences, serving as a bridge between scientific inquiry and human experience. By reflecting on alternate realities, art and literature encourage exploration of the unknown, inviting individuals to ponder their place in the cosmos while embracing the multitude of potential paths that lie ahead. Cultural narratives frequently intertwine with the concept of multiverse theory, offering diverse perspectives on existence and identity. This intersection reveals how different societies interpret the infinite possibilities that shape their understanding of life. Through folklore and mythology, these stories convey the idea of parallel worlds and alternate destinies, imparting wisdom about choices and consequences. They illustrate the belief that every decision branches into a new reality, echoing the principles of multiverse theory in a more accessible format. Artistic expressions, such as literature and cinema, further expand on this theme. Characters navigating through multiple realities often serve as metaphors for personal growth and self-discovery, reflecting the complexities of human experience. In this context, they confront their fears, desires, and regrets. Visual art also encapsulates this concept, presenting fragmented images that suggest a multitude of perspectives. Each brushstroke hints at an alternate narrative, inviting contemplation of what lies beyond the visible. These creative explorations act as a bridge between scientific theory and human emotion, fostering a deeper understanding of existence itself. As cultural narratives evolve, the multiverse serves as a backdrop for examining identity, morality, and the nature of reality, enriching the collective consciousness with its boundless possibilities. Ethical dilemmas emerge distinctly within a multiversal context. Each iteration of existence prompts profound questions about choice and consequence. In this framework, actions resonate across countless realities, challenging the foundational principles of morality. The implications of decisions ripple through interconnected threads, creating a complex web of outcomes that can be both enlightening and troubling. This region of thought invites contemplation of the self and its myriad expressions. Choices made in one reality may yield vastly different repercussions in another, prompting a re-evaluation of personal responsibility. The existence of alternate selves raises inquiries about the essence of identity. Are individuals defined solely by their actions? Or does the existence of infinite variations dilute the weight of their moral choices? In observing these ethical landscapes, the potential for compassion expands. Understanding that each decision is not isolated encourages a more empathetic approach to the dilemmas faced by others. The interconnectedness of lives across dimensions fosters a recognition of shared humanity, despite the myriad forms it may take. Exploring these ethical considerations allows for a richer dialogue about justice, free will, and the consequences of one's actions. This philosophical terrain not only deepens the understanding of morality but also underscores the significance of choices, transcending the boundaries of singular existence. The journey ahead in multiverse theory presents an intriguing landscape for exploration. The scientific community continues to delve into the implications of multiple universes, examining their potential to reshape fundamental concepts of physics. Researchers are probing the boundaries of quantum mechanics, investigating how various interpretations may offer insights into the nature of reality. These inquiries reveal a complex interplay between theoretical frameworks and empirical data. Advancements in technology may play a pivotal role in this exploration. Enhanced observational capabilities could allow for the detection of indirect evidence of parallel realities. Instruments designed to measure cosmic background radiation and gravitational waves might unveil signatures of alternate universes. Such discoveries would not only validate existing theories, but could also prompt a re-evaluation of the principles governing space and time. Collaborations across disciplines are increasingly essential, bringing together physicists, cosmologists, and philosophers. This convergence fosters a richer dialogue about the implications of multiverse theory, encouraging innovative approaches to long-standing questions. The vastness of possibilities suggests that the multiverse could, as theoretical models evolve and new avenues of research emerge, the quest to comprehend the multiverse remains an enduring pursuit. Each step forward enhances the collective grasp of reality, inviting deeper contemplation of what lies beyond our immediate perception. The infinite nature of the multiverse serves as a profound mirror reflecting the complexities of existence. In this vast expanse, Every choice made, every path taken, resonates through countless parallel realities. These realms, though often unseen, encapsulate the myriad possibilities that spring from individual decisions. The existence of alternate outcomes suggests a deeper interconnectedness, a web of existence that transcends singular narratives. Exploration into this concept reveals the nature of existence as fluid rather than fixed, where the boundaries of reality stretch far beyond conventional understanding. It challenges the limitations of human perception, prompting inquiries into the essence of identity and consciousness. Each universe presents unique laws of physics, different histories, and alternate versions of familiar beings, inviting philosophical discussions about fate and free will. The implications of the multiverse extend beyond theoretical physics into the realms of creativity and imagination, suggesting that every thought and action contributes to a vast, interconnected continuum. Embracing this notion encourages a broader perspective on life, fostering a sense of humility in the face of the unknown. In recognizing the infinite possibilities that lie within this expansive framework, deeper appreciation emerges for the intricate dance of existence. The multiverse,